it is the time to pay back. Hello everyone, Assalamu alaikum. This is Shoaib Farooqui again from the platform of That's the Point. And today we have a very interesting discussion coming to your way. And this is by inclusion of one of very special guest all the way from Malaysia, Ms. Sofiah Sarbuddin. She will be joining us for an interactive Zoom meeting. And the topic of today's discussion will be new advancements and development in the field of offshore drilling, deep water drilling. Ms. Sofiah Sarbuddin is currently working for a very renowned operator in Malaysia. She has been with Petronas and she has been with some of the very leading operators all around the world. She is an inspiration to all the female petroleum engineers. Being an engineer for last over 18 years, she have served Pakistan Petronas office, and we worked together and had a great time together here in Pakistan. She is very fond of Pakistan and people of Pakistan, and she's always very keen to spread and share her experiences. I have requested her to come and share her viewpoint as she is currently drilling deep water carbonates reservoir, one of the leading operators. She has a very diversified experience of drilling engineering, well planning, and well supervision as well. She have worked with Petronas in Pakistan, in Middle East, and then in Malaysia, Indonesia, and later worked with BHP in Australia, and also now working with another company in Malaysia. She is very well versed with her subject, and that's why I requested her to be with us and share her viewpoint on a very interesting topic, because this particular video is especially targeted to the new students, new petroleum engineers, early career professionals who are interested to know more about offshore drilling, deep water drilling, because in Pakistan we have very few occasions where we have such ventures for offshore. That's why our learning experiences are limited. Let's move forward to the recording of the session, and I hope you will enjoy it. But don't forget to subscribe. That's the point. Okay, good morning, everyone. Again, this is another very interesting session of That's the Point. I welcome you all, and I welcome our guest today. She is joining us all the way from Malaysia. Very dear and very, a old friend who is very well versed about Pakistan and the people of Pakistan. So I welcome Sofiah Shabuddin all the way from Malaysia for taking time out for this discussion. And today our topic is latest development in offshore drilling. Sofiah has been involved in offshore drilling since long. So I thought to have some latest development and latest technologies and what's going on in the offshore world. And we can hear from Sofiah. So thank you very much, Sofiah, for taking time out, and I hope you're doing good.
Thanks a lot, Shoaib. Likewise, really good friend and previous colleagues actually. Yep.
Okay, so my first question, and my audience is mostly students, early career professional, mid career professionals, people like us as well. And there are some senior people who definitely want to learn through your experiences. And I do these sessions for just for one cause, and which is knowledge sharing. So my first question is regarding what are the latest developments in offshore world when it comes to QHSC? And when we talk about latest development, they should be like what happened in last 5 or 6 years specifically.
Okay. I think in terms of safety of QHSC, it shouldn't really basically differ that much offshore versus land rigs actually. The only difference is, of course, offshore rigs tend to be quite remote. I mean, and also the accessibility is usually by chopper or by fast crew boats. So it's critical, I guess, in that sense. We have to make sure that it's a safe environment, um, not only while working. I mean, in terms of health, but also mental stress is quite a big deal in offshore environments, actually. Of course, you guys have heard mental health is picking up right now in the last few years. So, a lot of attention is being paid on that, actually. And in the recent times, especially in the last 2 years, COVID has affected all of us. And working in offshore environment in a COVID situation is actually quite different. Um, so, for example, in Malaysia, so what we do is I'm just focusing in COVID actually. So, in order to maintain a safe bubble offshore and to have it like sort of a mask-free environment and a safe environment, because once somebody has COVID, you have 140 to 160 people depending on the rig that you're operating in. So, it's really easy to spread. So the company I'm working with, for example, even though it's no longer required by the government, we still maintain like a 2 weeks quarantine to ensure that we are safe prior to going in. And then once we are just 2 days before boarding the chopper, we also do a test. So when we get to the rig, we should be free to work. So that's in terms of health. In terms of mental health, like for example, what we do right now is we have a lot of free services. Two different companies I worked in, because most people want it, especially in Asia, it's not very well spoken of. So we promote a free discussion such that it's confidential. So the company offers 3 to 5 sessions of psychiatric or basically a consultation or psychology treatment. So if at all you feel stressed or you feel uncomfortable, so they also kind of introduce online virtual helps as well. And if you come back from the rig, you can also visit these places for free, and they're paid by the company and it's purely confidential. So this is in terms of mental health in the last 2 years that we really look into. Um, in terms of HSC, we've got this. It's very focused in offshore. I'm not sure about land operations because I've gone off land operations for some time right now. But we have what guides us all is we basically have two different HSC things that we abide by. One is process safety. So we've got like must do process safety things that we look into. So process safety is basically keeping hydrocarbon in the string. So all those 10 process safety steps that we actually adhere to. So basically look into risk assessments, subsurface uncertainty, um, uh, things. Can't remember all of them right now, but there's like about 6 to 8 of them. And then in terms of personal safety, we have this 9 life-saving rules. For example, don't walk under load, get permit, lock out, tag out. Um, we used to have personal safety stuff as such as like alcohol, drugs, and speed limits, but we are moving more into the industrial one, so these are taken out of it right now. um, Basically confined space, gas testing. So these are personal safety aspects that in offshore. So anyone going offshore, we have to get them checked on process safety knowledge, awareness, and also the personal safety awareness. There are other things, for example, that we also look into, for example, depending on the operations, if it's a development campaign where we will have flaring and well testing and stuff. So we do conduct a very detailed risk assessment. So we conduct hazard studies, um, basically to see the implications that this situation have, and in terms of like noise as well as environmental impacts. So these are really looked into in detail, sometimes even months actually, to make sure, especially like when we're drilling in a platform where it's manned, um, there is no additional hazard to the existing facilities. Other than that, also in terms of environmental offshore, because we are drilling about 100 to 200 kilometers from the shore, right? So as you all know, it's the same as land rig. So land rig, we have pits to collect our cuttings and drilling fluid, whereas offshore, we can't just dump it in the ocean. So this is very specific to where we are operating. So different waters have different regulations. So for example, in Malaysian waters, we have to abide by the this MPM, which is our, we don't have a Ministry of Oil and Gas, so it's governed by Petronas. So they have this rule where we can only discharge cuttings that, especially if you're using oil-based mud, maximum 6% oil on cuttings. That too, the type of oil, the base oil that we use has to be biodegradable, and it's environmental friendly. So in terms of discharge, like for example, Norway has zero discharge. So whenever you drill, you have to take the cuttings back to shore. Whereas in Malaysia, we do process it on the rig itself, where the cuttings go through a conveyor, and it gets we get to actually dry the cuttings, and then we make sure that it's less than 6%, and then we can discharge it in the ocean. So when we do use anything for stuck pipes, sometimes they have any kind of oil and stuff like that. We cannot discharge that, so we'll have to take it back to shore and get it treated. So in terms of environmental, it is very restricted compared to land operations. We'll have to look into any sort of discharge and make sure that we do protect the environment accordingly. So before getting the rig in place as well, in terms of HRC, we do a seabed survey to make sure that it's not only safe for the rig to be parked, basically anchored, or if you use a jackup, that it will need to penetrate the seabed. So we'll have to take into consideration on the how the seabed is, and make sure that there's photos and there's a survey taken. And after the drilling activity is completed, we'll need to do a post survey to make sure that we keep it as what it was originally. So in Malaysia too, we have some areas where there is like marine parks, so it's protected. Um, so these places, if at all there's any drilling activity, then we'll have to have zero discharge. So we cannot even release any cuttings, even though it's cleaned and dried. There's no way. We just have to take it back all to shore. So yeah, so it depends where we drill and stuff. So in terms of environmental, there's a lot of things we have to look into compared to offshore drilling, onshore drilling.
Okay, thank you very much. It's a very detailed perspective, and I believe that offshore is usually a very challenging task to maintain the QHSC standards. But with COVID, after COVID, yes, that is my concern that now things are getting more complicated for the people, and you talk rightly about the mental health. So I request you to just bring this mic closer to yourself because your voice is not that much loud.
Okay.
So now the next thing I want to ask you about very briefly, what are the new technologies come across to your knowledge in last 5 years when it comes to offshore drilling? You just have to name them, just because details are available for the students and for people like us. We can always go and search out for those technologies, but just to get an idea, what sort of technologies you have seen because you are working with quite renowned operators all around the world. So that's why I put this question to your knowledge and want to get the answer for it. Thank you.
Thanks. So, in terms of technology, I guess back to basics. Um, when I was in land rig operations, the spread rate is about 20,000 to 40,000 a day spread rate. Whereas offshore rigs, it can range from, if it's a shallow water, it can range from 250, and if it's deep water, it can go up to 1 million a day. So every hour matters. So every hours can be like, I mean, it's not if you calculate it, it's about 40 to 50,000 per hour. So any technology that can reduce our flat time, basically not the drilling time, because drilling time you're making footage, right? And then flat time is like basically running casing or E-line. So focus in offshore drilling, we focus on flat time reduction, running casings, E-line jobs, or what are the cementing and stuff like that. So what the drive is for offshore, and especially in deep water, is to not eliminate, minimize it. So what we do is, for example, on a development platform, right? So we'll have 7 wells or 10 wells. So we will initiate like a offline cementing. So because we'll batch it, so we'll drill all the 12 and quarter inch section in one go. So 12 and quarter, then we'll keep skidding. So once we drill to TD, we'll run casing, and the cementing will be offline. So offline cementation is quite common in offshore operations because of you're drilling it in a platform. So the other thing we do is, unlike land operations where we have no water depth, so we have cuttings or mud to surface almost immediately. Whereas in deep water or slightly deeper water, when we start drilling our top hole, we have zero return. So basically we will touch the pit on the seabed, and then we continue drilling, and our fluid will not have a mode to go back to the surface until we have our conductor in place. So there is a technology called riserless mud recovery, where when you put in your we have installed like a funnel on the seabed, which has got just a side outlet and a hose connecting all the way to our rig. So this funnel and this hose is we have on offshore operations, we have ROV, like remotely operated vehicles, basically robots that we deploy, so they can kind of hook up the hose to the rig bag. So when we start drilling our top hole, we can actually have a return back to surface. So this allows us to basically measure all our fluid in, fluid out, so we know if there's losses, or we can also use a more premium mud, so because we're getting the mud back to surface, so it's a closed loop circulation. So riserless mud recovery is one thing. It's not so new, but it was initially introduced about 20 years ago, but it's been matured, and now it's quite commonly used offshore drilling, especially on deep water operations. Because we can also have returns while cementing, so we'll know our cement job is good on our surface casing. So the other thing, as I said, we want to eliminate flatline, right? So, and also want to make it safe, because injuries offshore is more hazardous because of the reaction time is longer to get a chopper and to the hospital. So you want to minimize, you want to automate most operations. So one of the other new technology is a wireless cement head. So once you have landed your casing, you nipple up your cement head, and because the stick up is quite high, so your cement head sometimes is about 1.5 meters away from you. So instead of having a man rider or a cherry picker, basically operated in a remote. So we have a lot of automation in offshore drilling. So even running casing, for example, I know in onshore is everything's back to basics. So a lot of man handling and stuff. Whereas offshore, for running casings, we will run it with a spear tool or a volant tool, where that tool itself can pick up the single joints, can make it up, can rotate, can pump, and has the ability to pick up the entire string weight. So this eliminates any man riding, cherry picker, stabber. Basically, it's just like reduces from 6-man operations to barely 2-3 guys. So yeah, and the rig up time is drastically reduced. But yeah, all this thing comes in a cost, but at the end it's much cheaper because of the spread rate being so high in offshore drilling. So these are some of the new technologies, like the riserless mud recovery, wireless cement head, plus a more advanced running tool for casing running tools. In terms of BHA as well, when I was in Pakistan, it's very simple BHAs. Here we run quite a robust BHA, basically very advanced, matured LWD tools that's even capable of taking pressure points as well as samples even. So we can eliminate E-line logging altogether, because that's another flatline activity, right? So we try to do many things with our BHA actually. So the BHA is pretty complex. Other than that, can't think of anything else that's any technology basically that helps us reduce flat time. No cost, additional cost is actually comparable to the spread rate.
Okay, so again, well elaborated, but this new terminology you have said is flat time. How you spell it? Flat?
Oh no, the flat time is flat time. Basically, when okay, the depth versus day graph. So basically, you're making whenever you are making hole and making depth, we call it having progress. So it's just basically, and then you have a flat thumb while running casing. You're not making any depth, right? So when you're running casing, you're cementing, you're doing wireline logging, you're not making hole. So
Okay,
whenever you're not making hole,
that is
yeah, we call
flat.
it flat time.
I got it.
Yeah.
So, as you mentioned, this is something new for us, that the use of robotics at the rig floor. This is something really innovative. So, my next question is just regarding the BOPs for the deep sea applications and handling water depth. Do you also you have seen or witnessed use of robotics while setting up and building up the BOPs downhole, or they are being done conventionally, still conventionally?
Um, so since Mokondo, right? Because Mokondo only had one single shear ram, and since then there's a lot of advancement towards offshore BOPs because the BOPs didn't really work in Mokondo, I mean, due to many reasons. So it's enforced that we have two shear rams. The requirement is increasing such that BOPs are huge now. So those days it used to be about 200 tons. Now it's about 400 to even 600 metric ton. Of course, with the water depth increasing, the bottle requirement, basically the nitrogen requirement, it keep increasing because to compensate the water depth, right? So there is, in terms of BOP advancement, of course, there is electronic BOP. So they use the solenoids and the pilots to minimize the weight and the huge structure of the BOP. So for BOPs on deep water and subsea wells, so it will need to be on the seabed. So in order to, so it is lowered with the rig. However, in order to connect all the hydraulics and the valves and stuff like that, we do have the ROV, which is remotely operated vehicle. So all subsea wells rigs, we will engage can't remember the company name, but the ROV, we will need the ROV. So it is like literally a robot with many different functions, and it's operated on the rig. So it can actually open and close the valves, and it can hook up stuff and all that. So it is a robot actually. Um, so that is also used to as our eyes on the seabed because sometimes it's about 2,000 meters. Sorry, 2,000. Yeah, correct, 2,000 feet. So 2,000 feet. So we do have like on the BOPs we'll have methane. Sorry, not methane. Oh my God, what is that called? It forms icicles. So we use methane to dilute it, methane and glycol. uh, what is it called? I can't remember, but I remember I'll let you know. So it does
Okay.
have icicles around it, and so that actually causes us not to open and close the valves properly. So we have these ROVs going and spraying methane and also glycol to de-ice those parts. So we don't have all these problems in a deep water environment. So yeah, so ROV is a must. And so the BOP does keep getting bigger, but they are advancing on the electronics BOP for deep water, so that kind of controls the size of it. And post Macondo as well, like since you couldn't shear the pipes, right? So like for the company I work with, we will need to do a shear test prior to mobilizing the rig for the campaign, like expected thickest pipe, and if completion string has all the control lines. So we will need to do a physical test and to see whether is it shearing all the control lines with the pipe. So that is a must. Uh, it's like a must before we mobilize the rig.
Okay.
So there is like a 4 week to 6 week rig startups that we do. So once we acquire the rig, we will make sure that okay the BOPs are functioning well. It can shear the thickest pipe along the control lines. Make sure that all the equipments are tested. So that itself takes us 4 weeks actually before we actually acquire the rig for any campaign.
One more thing which is very near to my heart: direction drilling. Direction drilling. When it comes to direction drilling, any new innovations which you have noticed in last 5 years, especially for drilling laterals or multilaterals through offshore platforms?
Not anything new in that sense. However, it's also moving towards automation. So during COVID, Baker is one of the companies we worked with. They could not mobilize the directional drillers because of this quarantine and stuff like that. So they actually drilled the well from the office. So they were not on the rig. So this is one thing that was new in the company I was in before. So since they couldn't mobilize, so they got all the screens set up in the office, and they had the MWD guys on the rig. So they actually drilled that section from the office. So that they do have it quite matured, I think, the whole setup. When we used it, we didn't plan for it. It was a sudden no choice. But with the current operations that I'm going to be drilling the next time, I'm going to be drilling at 7 exploration wells. So we are actually planning for it. So we'll activate it in the event we need it. So we're getting it all set up in the office. So in case the guy can't go or there's something, we can drill it from the office. So yeah, so we reduced the personnel quite drastically. So that's the only advancement. Yeah,
Yeah, so
in the direction.
what I have learned that most of the service lines and the technologies are going on automation mode, emphasis on less people at the location, developing effective contingencies, and again on top of all, the mental health, which is you explained the core aspect of handling offshore operations. So. Just my last question is how, just for youth and youngsters, what depths of wells we are looking at? When we talk about the
I'm
vertical,
sorry, I didn't get your last sentence.
what are the depths of offshore wells we are looking at right now when it comes to vertical holes, and how far you have seen drilling a lateral is being drilled, like 1,000 feet, 500 feet, or more than that. So just shed some light on the depths of the wells.
So the last few years, I've been basically drilling carbonate wells. So they are quite popular in Malaysia. So these wells range from 3,000 to 3,500 meters. So depending on the carbonate structure, so some of it's pinnacle, it's basically like a mountain, and some of it is like a platform, so it's a flat structure. So these flat structures, we will usually go on horizontal well. So those wells also range about the same meterage, but they are like basically as soon as we set our 958 casing on 8.5 inches going to be across the reservoir. So if the reservoir is really thin, then we will geosteer actually, just to make sure we don't exit the top of carbonate. So we'll geosteer 90 degrees. So that section alone can range from 600 feet all the way to what 6,000 feet. So we've drilled up to 6,000 feet of the 8.5 inch reservoir length. So if the oil rim or the column is really thin but really long, then yeah, that's what we do. So some of it is very thin, but we just thin as in just to give you about 100, 200 feet, sometimes very thin. Whereas some are pinnacle, so they're like a mountain that is about 500 meters. So it depends on the reservoir type. So yeah, so vertical wells about 3,000 meters, horizontal the same as well because it depends on the top of carbonate. So yeah, so horizontal wells you may basically look at the reservoir section, which is about 6,000 feet.
Okay, so that's it. Thank you very much for
Oh, I
being.
cannot hear you.
I'm saying that thank you very much for being with us. That's it. I'm sure that people here will enjoy this discussion. Quite new things have come to their knowledge for sure. And at last, anything you want to say about Pakistan? Because we really miss you in Pakistan.
I also miss Pakistan. Pakistan is the best country till today for me. I miss the food, the people. Yeah, it was. Very nice 5 years I was there, so I do miss it dearly. Hope to visit again sometime soon,
Sure, sure.
especially the clothes. Miss the dresses.
Okay.
Yeah.
Okay. Thank you very much, Sophia. Take care. I'm really pleased to have you with me on this collective discussion for That's the Point. Wish you all the very best in life. Stay blessed. Bye.
Thank you so much, Shoaib. Okay, bye.